In this example, we're asked to find the amount that results from a $1,000 investment after a period of 8.5 years at various interest rates. Notice in parts A, B, C, and D, the interest rates are all 6%. But what's different is, for example, in A, it's simple interest. In B, it's compounded semi-annually, so twice a year. In C, it's compounded quarterly, 4 times a year. And in Part D, it's compounded monthly, 12 times per year. So let's look at Part A, and we want to find the amount in the account after 8.5 years after that $1,000 investment with simple interest. So we'll just take our original amount, $1,000, and add the simple interest to get the amount in the account after 8.5 years. So let's calculate our interest. I equals PRT, principal times rate times time. So we've got a principal of $1,000. So if we want to write this over here, P equals 1,000. Our R is 6%, and we want to write that in decimal form, so that's 0.06. And we've got our time is 8.5 years. I'll write it as 8.5. So I'll fill in 1,000 times 0.06 times 8.5. And if we enter that into a calculator, we'll get $510. So if we earn $510 of interest, then the amount in our account will be that original amount, 1,000, plus our interest, 510, and that will give us a total of $1,510 in that account. Let's look at Part B. Now, instead of just calculating the interest on that original principal, we're going to compound the interest semi-annually, so twice a year. So this is where we're going to calculate the interest based on the principal plus the interest, so interest on interest. So we still have the same P and R and T, but we've got now compounding periods. So if it's semi-annually, that's going to be twice a year. So remember our formula for compound interest, the amount in the account after T years is equal to the principal P times 1 plus R over N to the NT. And we've got, again, R is the annual interest rate, T is the time in years, and that N is the number of compounding periods. So in this case, our N is going to be 2 because we're compounding twice a year. So we'll fill in our principal, again, 1,000 times 1 plus our R, 0.06, over N, which is 2, to the NT, so to the 2 times T, which is 8.5. And I would strongly recommend that you enclose the entire exponent, the NT, in parentheses, and that will be a good cue when you go to enter this into your calculator. So if we want to enter this, we want 1,000 times the quantity, 1 plus 0.06 over 2, close those parentheses, and now we want to raise that to the quantity, and this is why I reminded you to put parentheses around the exponent, because here we have to enclose the 2 times 8.5 in parentheses. Otherwise, the calculator will only square it instead of raising it to the power 2 times 8.5. Another option is just to multiply 2 times 8.5, which would be 17, and then just raise it to the 17th power. So if we hit enter, we're going to get about $1,653 if we round up to the nearest dollar. So this is going to give us approximately $1,653. Now if we compare this to the simple interest rate, that makes sense because if we only calculate the interest once on the original principal, it makes sense that that would be less than if we compounded it twice during the year. So we compound it once halfway through the year on the original amount, and then we add that interest to the original principal and take interest on the interest at the end of the year, and that would give us the $1,653. So if we look at Part C, 6% compounded quarterly, now again our N, the number of compounding periods, will be 4. So if we fill in here, our A equals our principal, P times 1 plus R over N to the NT. And you will need to memorize this formula. You'll need to memorize the formulas for compound interest in this section. So we'll fill in our 1,000 for principal times 1 plus our R 0.06. Now our N is 4, and now our exponent is going to be 4 times that 8.5. Now on your calculator, you can just go ahead and hit second entry, and it'll bring up your previous entry, and you can just change your 2, your compounding periods, your 2. We can change that to 4 for the quarterly, and then in our exponent, we also have our 4. And we hit enter, and we're going to get $1,659 if we round up to the nearest dollar. So approximately $1,659. So not much higher than the semi-annually, just a few dollars more. And then finally the monthly, so again, we would expect that we get a larger amount as we increase the number of compounding periods, but you'll see that it's not as much as you might think. So with compounded monthly, we're going to get N is 12. Our compounding periods would be 12 for the 12 months. So we'll fill in, again, our formula, P times 1 plus R over N to the NT. So we'll get 1,000 times 1 plus 0.06 over 12 to the 12 times 8.5. And again, you can enter that into your calculator, and you're going to see you're going to get approximately $1,663. So again, just even a fewer dollar difference here between the quarterly and the monthly. So while it's true that increasing the number of compounding periods will increase the amount of money in an account, there is a ceiling, and we'll talk about that in the next video.